So thank you very much, Marek. It's a great opportunity to describe a little bit our master's program. My field of research is completely different from that of Professor Novoselav. I work in program verification, that is to say, making sure that the programs that, as Sergei Belousov said, run the world, own the world, that these programs actually work correctly, and which is a huge challenge. I mean, how do we know that they run correctly? One of the characteristics of SIT is that there's a really close connection between research and education. There was a question about how accessible. You asked Mark actually how accessible our top people are. Well, you can see how Professor Vasyolov is. You should have seen these scenes when we had another Nobel Prize, Wolfgang Ketterer from MIT, mesmerizing a couple hundred local high school students from Schaffhausen with experiments, very concrete experiments on what happens at very low temperatures. This is our principle. We want to take the best experts and make them directly available to our students. And our first own educational program is this great master in computer science and software engineering that we're launching now. The first students are going to come in September. Here are 7 reasons to join this program, which has already been mentioned by previous speakers. It's the only master that really focuses both on software engineering, which is a fundamental field, which again runs the world, and computer science in general, because you cannot do software engineering without a very strong and both deep and broad computer science background. We have a unique program. There's really nothing like it in the world, in which we are combining topics from technology and from management and leadership. The developers are there. Developers are a dime a dozen. And if your CV says developer, okay, it's not going to impress that many people. What companies really want, what they are dying for, is people who have the technical savvy, but also the management and leadership skills. And this is what we're offering. People, we've made this point already. We have a slate of absolutely world-class people in software engineering, in management, in leadership, but also in neighboring fields, in physics, as you can see, in digital management and other fields, so in a completely pluridisciplinary context. We are applying novel models of teaching, which I'm going to talk about more in a second, flip learning. We have fascinating research and industry partnerships with all kinds of partners, both in top universities and in companies. We offer the possibility of double degrees with top 10 universities in the world, such in particular as our original partners, Carnegie Mellon University in Pittsburgh in the US, and National University of Singapore, which is where our student Emmanuel Gael Guedia will talk to us from in a minute. And we offer attractive scholarships. So if you could go to the next slide. We offer, there are software engineering programs out there, actually not so many, but there are computer science masters. What we offer, which is not to be found anywhere, is this unique blend of 3 aspects: technical skills, really solid computer science and software engineering. We're certainly not doing anything on the cheap here, and we're going into the depth of these technical topics. But then also management skills for the kind of positions that Sergei Belousov mentioned earlier. Chief information officer, chief product officer, chief innovation officer, which companies really, really need and have trouble filling, and leadership skills. Next slide. So to be a bit more precise, of course, I'm not going to go into the full details of the program, but examples of courses in all 3 areas are the following. I'm going to pick a few in each. On the technical side, quality is, of course, the name of the game today. Data science, cyber protection. The world runs victim to attacks all the time, and we cannot accept this. Software engineering, my field, software engineering is not just about programming. Software engineering is about building large systems that are going to continue being used and being developed for years by tens, hundreds, sometimes more people, and which are going to undergo many different changes, many different innovations going through major cycles. So this is a full-scale engineering issue, full-scale engineering enterprise, which needs techniques from many different areas. Architectural strategy, dynamic analysis. Professor Novasiolov mentioned how important deep learning is to physics and new materials in particular these days. So we're going to have in-depth courses on these topics. System protection, quantum informatics, which is the new kid on the block in the computing field today, and others. Management, things like programmatic marketing, product design, transformational change management, product vision, and then leadership. Sergey emphasized a lot the importance of entrepreneurship. Modern society has been moved forward by people like Bill Gates and Steve Jobs and Larry Ellison and of course Sergey Belousov, and we want to train the next generation of entrepreneurs. Human and social psychology, agile leadership. This is one of the areas in which I have worked. The principles of agility and a customer-centric mindset. So these are just examples of the courses that we offer. Next slide. So the program is largely the brainchild of my great friend and colleague Mauro Pezzei, who is formerly from the University of Milan and from the University of Lugano in Switzerland. He is a very influential member of the software engineering community, editor-in-chief of the main journal in the field, and with a huge international experience. And I've been, if you go to the next slide, I've been working hand in hand with him. My experience has been at ETH Zurich. I was interested by the question a few moments ago about, why go to SIT and not to ETH Zurich? So, I spent many happy years at ETH. I was even chair of the computer science department. And don't expect me to say anything negative about ETH Zurich, which is a fantastic place, but it's an old place. It's a traditional place. So it has the virtue and the benefits of its age and of its experience. And if you're looking for something a little bit more adventurous, something a little bit more multidisciplinary, where you can brush elbows with a physicist one day, a sociologist the other day, a political scientist the next day, and a boring software engineer like me the next day, well, come and try SIT. It's definitely going to be different. Next slide. And you don't get just professors. We talked about this fantastic network of people we have who are not necessarily on the register of the faculty at SIT, although they will be teaching courses, but they will not necessarily be full-time professors. They come from all walks of life. I mean, many of them are from academia, some of them are from industry, many of them are actually straddling the world of academia and the world of business. And so, where else can you talk to Arthur Eckert, who is one of the great innovators in quantum physics, to Barry McManus, who is an expert in human psychology and interrogation techniques, with Bruce Score, who is one of the leading people in agile development. And of course, well, you just heard from Kostya Novasiolov, and you can see the kind of thing that you can benefit from at SIT. So this is one of the great opportunities at SIT. It's to get out of your shell. You are going to have all the courses, all the credits, all the exams, all the dotted I's and crossed T's that you would have in any good university, but you are going to have more of that. You are going to have opportunities all along. Next slide. Our mode of education is blended. So we didn't wait for the COVID catastrophe, which is, of course, is forcing everyone to rethink how they teach. But when you look at what many universities do when they say we're going online, well, they take last year's lecture, they videotaped it, and they put it online. Well, this is not very exciting. It's okay for a couple of months, as we have had in the spring. But imagine going like this for months and years. And it's not just the matter of COVID. It's that we have technology today in the same way that techniques of artificial intelligence and machine learning have revolutionized so many areas of business and technology. They can help us revolutionize the world of teaching. So of course, personal attention is always going to be fundamental. On-site education is going to be a key part of SIT education, but we are in the process of devising, in particular with our Alemira branch, new modes of teaching which combine the best of in-person on-site teaching and online remote education. And this also includes things like industrial projects and the kind of things that you do not typically find in standard traditional curricula, interaction with, of course, top-class academic instructors, not just at the level of the professor, but also at the level which is very important for students of teaching assistants, people who have the time to take care of you, to understand your special skills and your special needs, and of course, seminars, interviews with world leaders. And it's not just taking lessons online. The systems that we're building are going to be personalized. They will know about you. They will use AI techniques to make sure that the education that you receive is absolutely unique and tailored to your specific personality and mode of learning. Next slide. So some of the original aspects are following. So what you see on the right is an example of a Roborace car. Roborace is an international effort, an international competition, in fact, to get to Formula One cars, which are completely driven by software. So the hardware is the same for everyone. What differentiates the various contestants, including SIT, is the intelligence, right? It's the software. So it's an example of the kind of projects that we are going to offer our students. Our master's program has a capstone project where students work in teams to build something really ambitious. Summers will be used for full immersion in industry internships. We have an industry thesis, a startup thesis, and of course, again, access to world industry leaders and constant interaction with industry so that you can start working on your career, not when you graduate, which is typically too late, but all throughout your career and your studies at SIT. Next slide. I'm not going to go into the details of the program, but there's really two essential points to be mentioned here. One is that the master's program that we offer is a full-fledged European style, a European standard master's program. So it's not a reduced program. We will have other programs. We have executive programs, we will have executive masters. There are room for these, they're very important, but this is not what this master's program is. It's a standard program. For those of you who are familiar with the details of a European system, there's a notion of ECTS, which is basically a European standard way of counting credits, making it possible in particular to exchange students between universities, and if you want to go abroad for a semester or two. And so in the top range of, in the Rolls-Royce, so to speak, of a European master's program, it's either 120 or 140 ECTS credits. So we have three variants, and we can tailor the program to individual needs. The classic variant is 4 terms, four semesters, starting this fall with a summer internship. There's a fast variant, which is 3 semesters, but still the same number of credits. So it's not on the cheap. It's compressed. It's for students who want to work very hard, maybe students who are being sent by their companies. So they're going to do the same amount of work. They'll just do it a little bit faster. And then we have the really exciting possibility, which we have already inaugurated ahead of this program with our previous program, of a double degree with our partner universities, currently National University of of Singapore, which is where Emmanuel hails from, and Carnegie Mellon, where essentially you spend the first year in Schaffhausen or with a mix of on-site and remote education, but based in Schaffhausen. And then you spend your second year, your third and fourth semester at one of the partner university, and so you get a double degree, or more precisely, you get 2 degrees. You get a degree from us, and you get a degree from them. Next slide. So admission and scholarships, as was pointed out by Mike in particular many times, the place to go is cit.org/admissions. And basically, there are 2 ways to get admitted. The simple way is you have a bachelor in computer science or a related discipline from a recognized university. So this is the default. But you know, again, coming back to the reference with traditional universities, we want to be flexible. We don't want to lower the standards. That's not the point. But in all traditional universities that I know, let's assume you want to do robotics, and for robotics you don't want to do computer science, and your bachelor's degree is in mechanical engineering, which is a very good preparation. Maybe you are missing a few things, but it's very good to be a mechanical engineer. Well, in the universities I know, you are not going to get admitted into a master's in computer science because you don't have the right degree. Well, I'm not saying we will admit you, but we will look at you. We will look at your CV, we will interview you, and we'll see if your strengths here compensate for your possible weakness there. The deadlines are very flexible. We use the shorter the better, the sooner the better. Let me state this clearly, because it definitely facilitates the processes, in particular for things like visas if you're not Swiss or EU. So the deadlines are September 1st and September 12th, respectively, for non-Swiss, non-EU, and for Swiss/EU. For a fast track and joint degrees, you know, the exact kind of program among the 3 that I presented in the previous slide, there's some flexibility. You don't need to choose right away. You can adapt as you go. And with respect to scholarships, we have many scholarship opportunities available. Basically, if you maintain an excellent grade point average, you know, if you're a good student, then we will give you a scholarship. Next slide, please. So, you know, one of the pleasures of being in academia, there are a few burdens, but one of the pleasures of being in academia is that you get to meet students, you get to work with great students. And one of these students is Emmanuel Gael Guedia, whom I actually met in another university and who followed to SIT. He is one of our showcase students. He is currently at NUS, National University of Singapore, and I'm really happy to give him the word and give us a little bit of the SIT experience as seen from one of our very first students. Emmanuel, the floor is yours.
Thank you, Professor Meyer, for your honorable and kind introduction. I'm Emmanuel Gael Guedia. I am an SIT student studying at NUS in Singapore, information security as my major. So I graduated a bit more than 2 years ago from Innopolis University in Russia, where later on I started my career as a software developer and also a bit of DevOps. But now I am an intern in the research and development lab at Acronis in Singapore. Next slide, please. So what I need to mention here is that prior my master degree, I didn't have a professional experience in machine learning or cybersecurity. But thanks to SIT, I was assigned good supervisors from Acronis who like kind of drove me through my learning process. And now I've made major improvement, and I have major improvement like that helped me through my career and my dissertation, because the project I'm working on is at the same time the topic of my dissertation that I'm supposed to defend by late November, which is also supervised in academia by NUS. Next slide, please. So first we have to know what is a malicious URL and how we can use machine learning to fight against those malicious URLs. We might all be targeted every day by those like URLs that try to either infect our computers or smartphones, or try to extract some information, like critical information from companies, from individuals, bank card informations, and this is become more and more popular. So machine learning can help to automate the process to avoid all the burden, like to avoid human mistakes, and to make it more automated, more faster and more efficient. So machine learning here will be used to automate the detection of malicious URL, and make the IT world a bit more safe. Next slide, please. So as you can see here, machine learning is a very considerable type of attack. I mean, malicious URL is a very considerable type of attacks. These days, like, they can appear in any shape. You can find them on legitimate websites. You can find them like from receiving emails, like someone trying to imitate existing popular brands and try to trick you into giving out your information or installing a software on your computer. And it becomes expensive because you have to train your employees to detect those, even though it's not easy, but the companies these days have to invest into that, which is not always easy for small businesses. And as Stas Protestov said, it's mentioned, these days, even into elections, people are trying to bring some sort of trickery into, intruding themselves into elections. Next slide, please. So we had to come up with a solution that will be, of course, better than the existing one. I need to mention that the existing ones are more focusing on the phishing type of malicious URL, while Acronis is more focused on the all type of malicious URLs. So, but the solution, we should make sure that we don't let the wrong URLs go through, and we should also make sure that we don't block the correct ones. That's why it's very important for us to have a low rate of false positive and also a low rate of false negative. Next slide, please. So far, we've managed to achieve to perform better in some sense than the current state of art, trying different approaches with the set of features we could extract from those URLs. We were able to try those features with different machine learning algorithms, and every time we managed to outperform the state of the art techniques. But there's still a place to improvement because the false negative rate is still high for such a solution. According to the business, it might be okay, but in this specific case, we still need to improve those results. Next slide, please. So later on, after those improvements, what I need to do is to finish my dissertation, which hopefully will also allow me to publish my work to a scientific journal, and have that solution to be integrated to Acronis Cyber Protect, because yes, is a product that they invest into this product actually is a good solution. So they plan to integrate that solution to their existing product. Thank you very much.